Hello Maya. Have you ever wondered how we can predict the weather?
Or how scientists know how many Sumatran tigers remain in the wild?
Or even how election survey results can be predicted from just thousands of respondents?
The answer lies in one field that might sound boring, but is actually incredibly powerful: statistics.
So what we're gonna do today is, we're going to dive into the long journey of statistics, from ancient times to becoming a vital tool in wildlife conservation.
Ready? Let's begin.
The story of statistics began 1,000 of years ago. The word statistic itself comes from the Latin word statisticum, which means state.
Why? Because statistics was born from the state's need to govern its people.
Around 3,000 years before Christ, the Egyptian and Babylonian civilization were already conducting censuses, counting the number of people, livestock, and harvests.
The purpose was simple: for taxation and organizing armies.
Let's go to ancient Rome, shall we? So, in ancient Rome, Emperor Augustus conducted a massive censuses to determine how many citizens had to pay taxes.
Even in the Bible, a census conducted during Jesus' birth is mentioned.
So, initially, statistics was only about counting and recording data. There wasn't any complex analysis like we have today.
Jumping to the 17th century, a major change occurred. Two French mathematicians, Blaise Pascal and Pierre de Fermat, began exchanging letters about gambling problems.
Yes, that's right, gambling. So they were trying to answer how do you calculate the odds of winning in a dice game.
From this simple question, probability theory was born, the mathematical foundation of modern statistics.
This turned from statistics, from merely recording data, into a science that could predict the future based on past data.
And in the 18th century, an English clergyman and mathematician named Thomas Bayes developed a theory now called Bayes' theorem,
A method for calculating probability based on new information that is continuously updated.
In the 1800s, Carl Friedrich Gauss discovered the normal distribution, or bell curve,
A pattern that appears in almost all natural phenomena, from human height to a measurement errors.
Entering the 17th century, statistics rapidly developed into a standalone science.
Carl Pearson, an English mathematician, developed many statistical methods still used today, such as correlation and the chi-square test.
He also founded the first journal focused on statistics.
Then there was Ronald Fisher, the father of modern statistics. Fisher developed several key concepts.
First, hypothesis testing, a method to test whether research results are truly significant or just coincidence.
Second, experimental design, a way to design valid research.
And third, ANOVA, a method for comparing multiple data groups simultaneously.
Fisher worked in agriculture, trying to figure out which fertilizer was most effective.
From this practical need, statistical methods were born that are now used worldwide, including in conservation.
Now, let's look at how statistics is applied in conservation, the protection of nature and wildlife.
For example 1, counting the Sumatran tiger population. We can count tigers one by one in the forest, right? It's too fast and dangerous.
So, researcher use the capture-recapture method with camera trap.
So, here is the process. Install cameras at various points in the forest.
The same tiger might be captured by cameras multiple times.
By using statistics, we can estimate the total population based on how often the same tiger appears.
This uses probability principles developed hundreds of years ago.
For example 2, predicting extinction. With population data from year to year, conservation experts use regression analysis to predict several things.
Will a species population go extinct within 50 years? Or maybe 40 years?
How much minimum habitat is needed for a species to survive?
Is the ongoing conservation program effective? Is it?
For example 3, monitoring ecosystem health. In national parks, researchers take samples of soil, water, and plants from several points, not from all areas.
With statistical sampling, they can determine the condition of the entire ecosystem.
For instance, if 30 out of 100 water samples show pollution, we can estimate that approximately 30% of the area has the same problem.
All of this is done with hypothesis testing. Is this pollution significantly higher than last year?
Statistics provides objective answers, not just rogue estimates.
So Maya, we know that statistics has come a long way. From tests and censuses in ancient Egypt, dry scheme in France, agricultural experiment in England.
To saving Sumatran tigers in Indonesia.
Statistics isn't just numbers on paper. It's the language we use to understand the world.
To make informed decisions and even save our planet.
So everyone, the next time you see a graph or a percentage, remember, behind those numbers is a long story spanning 1,000 of years.
And perhaps the future of endangered species.
So, thank you for you guys that have been stayed for this long. Thank you for watching, and I hope you learn from our videos. Thank you.
And share this video with friends who care about science and conservation.